So hi guys, I'm Shubham Agrawal, and in today's lecture we are going to study about structures in C. So as you can see that we have studied arrays and pointers, then we have studied about strings, and then we have another user-defined data type. So structure is a user-defined data type first of all. Okay, yes, data type. Okay, so we if we have an array, okay, so array contains same type of data element. But if we want some different data type of data element, so then what should we do? Then in that case, we have a structure. Okay. So structure is a user-defined data type which can contain dissimilar data items, means which can contain different types of elements of different data type. Okay. So if I want to store a record of a student, okay, so then I will have a roll number, then I will have a name, etc. Okay, so this will be a structure and it can contain an integer field, then it can have a string that will be a character array. Okay, so if my requirement is something like this, then I have to use structures in C. And you can expect at least one question from this area. Means it can be combined with any other topic like pointers and something. Okay, so you can expect one question from this area. Okay, so let's study. So let's first move to our today's agenda. Okay, so our today's agenda is something like this. Okay, so we will first see what are structures, then we will see the declarations of the structure, then we will see the initialization, then how to access the member of the structures. Okay, so there are two ways. One way is direct using dot pointer, and then other way is from arrow pointer if we are using pointer. Okay, so we will see about that. Then we will study structure of arrays, I mean array of structures. Then we will see the pointer to a structure. Then type def is most commonly used with struct keyword, so we will see the use of that. Then we will study about union, enum. Okay, then we will do some gate questions based on structures. Okay, so let's move to our first topic. So as we have seen that structure is a user-defined data type, okay, and it is a collection of dissimilar data items, means different data items. Okay, so if I want something like this, I want a student record. Okay, so in this, I want first the name, okay, of the student. So let's say the name can take 20 bytes. Okay, then we have int roll number. Okay, then we have float percentage. Okay, so I have a student record in which I have a name which is of type char array. Then we have a roll number which is of type int. Then we have a percentage variable which is of type float. So it in this we have three different data types. Okay, and we are packing them into a one structure, and this will be our user defined data type student, which will contain three fields. First will be name, second will be roll number, and third will be the percentage. Okay, so this is the syntax to declare the structure, in which we have a structure name, then we have a data type and its name, then we have data type 2 and then its name, then we have data type 3, then its name. Okay, so when we declare the structure, so we can't initialize the structure. So we will see in the later slides why. Okay. So here also in the example, the same example is shown with two data members. One is a name and second is ID. So this is our structure. Now let's see how to declare a structure. So this is the syntax for the structure. Now let's see how to declare it. Okay. So the first way to declare a structure. Okay. So if we have a structure of point in which two variables are there, x coordinate and y coordinate. Okay, so two data members are there in this structure, and here p1 and p2 will be the type point. Okay, so p1 will be a structure member of point. So there is two way in which we can define the structure variable. So first way is at the time of declaration we can define. Okay, so here we have defined our structure, and then we will define our variables here. And second, in the main function, like first we have to use the struct keyword, then the name of the structure, and then we have to give the name of our variable. So in this way we can declare our variables for struct. So here when I define the structure, so here no memory is allocated. Okay, for int x and y, it's only specifying that it will contain, if we define a variable of pointer if we define a variable of point type, then it will have integer data x and integer data y. Okay, but here the memory will not be allocated because it is only a declaration. Okay, so when we uh, means when we take the variable from this struct, means when we declare the variable using this struct, so this is declaration, and this is the instance creation, means here we are creating the instance of this point. So p1 and p2 are two student object, and the memory will allocate to them. Okay, one is for x, another is for y. Okay, so this will something be like this. Okay, so when we define the p1 and p2, then the memory gets allocated, but at the time of declaration no memory will be allocated. Okay, so one second. Yeah, so no memory, and here memory will allocate it. So this is our declaration. Let's see how can we initialize a structure. So since we know that we can only declare a structure, so here we can't, when we are declaring a structure, we can't initialize it. So this is absolutely wrong because we can't initialize the structure data members. Okay, so here we are locating 0.0, means we, we are assigning 0.0 to real part, but this variable is only declared here. It is not defined or something. So that's why no memory will be allocated at the time of declaration. Okay, so it is a incorrect syntax to declare to initialize a struct. Okay, the correct way to initialize is this. First, we declare our structure and then we initialize. So to initialize the struct variable, we can use curly braces and we can assign the values according to the data type that are present here one by one. So real part, so in this case, the 10 will be assigned to the real part, and 12.5 will be assigned to the imaginary part of this complex structure. Okay. Yeah. So let's see how we can access the member of our structure. So here we have defined a structure which is which contain two variables, real and imaginary part. So to access the member of this structure, so we have C1 of type complex. So to value this, to access the data member, so we can use here dot operator. Okay, dot operator. Okay, so C1 dot real. So in this 10.1 will be there. Then we have C1 dot imaginary. In this 20.5 will be there. Okay, so in this way we can also initialize the value, okay, of the structure. Okay, yeah. So if we are not initializing the value of C1, then it will contain the default value, which can be a garbage value if it is a local variable, but since it is a global declaration, so it will be maybe it will contain 0.0. Okay, so it depends, okay, whether we are declaring it local or whether we are declaring this structure as a global. Okay, here we have declared it outside the main function, so it is a global struct, and we can use this structure in any of the following code. Okay, in any of the function. Yeah, so here we are defining a variable c1 and we are initializing it with 10.1 and 20.5. Okay, and when we print this value, so it will print something like this: 10.1 plus I 12.5. So it is a representation of complex number. So we can store a complex number in this form using a structure. Okay, so here we are using the dot operator. So to access the member of our structure, we are using dot. Okay, so let's see, let's move on. So then we have a pointer to structure. Okay, so what is a pointer to structure? Okay, so suppose that we have declared one structure with we have declared one variable of the structure complex, so c1. So memory will get allocated, and memory will look something like this. So first 4 byte will have this real part, and another 4 byte will have imaginary part. Okay, sorry, yeah, will have the imaginary part. Yes. So here 10.1 will be present here in floating point format, IEEE 754 format, and I'm just writing the value here, okay, for now. So it will be of 4 byte. So here C1 will have this. So this is our C1 variable. But if we create a pointer variable of this complex struct type, then P1 will be there and P1 will point to this C1. Okay, so so to access the data member using pointer, then we have to use the arrow operator. Okay, arrow operator. So the arrow operator is hyphen then greater than symbol. Okay, so here p1 arrow real, so it will print 10.1, and then we have p1 arrow, sorry, imaginary, so it will print 20.5. Okay, so this will be our output. So our output will be here 10.1 I 20.5. Okay, okay, so here we have accessed our struct variable using a pointer variable. So if we are using a normal variable c1, then we have to use dot. If we are using a pointer variable, then we have to use arrow. So we have to remember this point. Okay, yeah. So we have variable for dot, a dot, for dot we have variable, and for pointer we have arrow. So just remember this point. Okay, yeah. So let's also see, yeah, let's do one gate question first. Okay, so in this we have defined a structure, okay, in which the structure name is out node, and it contains three variables x, y, and z. Okay, then we have one struct variable here in which we have initialized this three value x and y. So we have, it is a struct, suppose its name is p. Okay, and we have, okay, in first bit byte, so this will be 1 byte, this will be 1 byte, this will be 1 byte, and here we have 1, then we have 0, and then we have a plus 2. So a plus 2 will be, it will be c. Okay, so when I add in a, I add 2, and when we assign this value, so a's value is 97, and 97 plus 2 will be 99. So when this 99 will get assigned to this character z, so it will become character c. So here c will be present. Okay, so just let me remove and write it. So here it will be c. Okay, yeah. So now we have this array, and now we have a pointer q of this our node type. So it will point to this p. Okay, so it is a variable p, and then we have a q which is pointer to this node, and it is of type out node start. Okay, then we are printing the character. Okay, so first we are so this q will point to the first address. Okay, here this whole node it will point to, it will not point to first byte but the whole node, because when I increment this by 1, so it will be incremented by 3 place. So q, when q plus 1 will be something here. Okay, after this, because the when we increment a pointer, so it will increment by the size of the type. Okay, size of the data type, and here the size of the data type is in this 3 bytes, 3 character are there, so it is of 3 byte. Okay, 3 bytes. Okay, So first I will convert this pointer to a caret star. So now the Q will point to this first bit, okay, and I will add 1 to it. So first we have converted. So now we have reduced the type to char, okay. From our node to it is now become char type, okay. We have typecasted it. So now it will not increment by 3, but it will increment by 1, okay, okay. So when I increment it by 1, so it will come here, okay. So Q will point Q1 plus 1 will be here. Uh, Let me write star Q1 plus 1 will be here, and the value at this node will be 0. So the 0 will be printed. So here the single quotes will not be printed, because when we print a character, then the compiler will not print the means the program will not print the quotes here. Okay? So quotes will not be printed. And when we have char star Q plus 2, so it will point to this. So we have char star Q plus 2. So it will point to this character C. Okay. So its value will be C. So C will be printed. So our output will be 0, comma C. Okay. So our correct answer would be A. So this is not correct. This is not correct. Okay. Here they have not mentioned the means it is absolutely wrong, because um, we can't have something like this. Okay. So here they have not mentioned the codes also. So it will definitely be the wrong output. Then we have A plus 2. So it is in single quotes, only one character will be there. So they have taken 3 characters here. So it is also wrong. It is wrong because the single quotes will not be printed. So it is also wrong. So the correct answer is A, 0, comma C. So this was asked in GATE 2018, and its answer is 0, comma C. Okay. Now let's see type def. Okay. So type def and relation of struct keyword. So if we don't use, so we have studied previously that type def is used to assign new name to a variable. So here we have the existing data type and then the new name. So its syntax something like this. So we have type def keyword, then we have the existing name. Suppose it is long, and then we have the new name, that is LL short form, and then we end it with semicolon. Okay. So this is the uh, means this is how we can rename a data type or something with the type def keyword. So we can use the type def with struct also. So without type def, this code is something like this. Okay, so we have a struct point. In this we are declaring a pointer variable in which we are assigning 1 and 3, and then we are printing. So it will print 1 and 3. Okay, but here we are defining this struct point. So we have to define the struct keyword here, means we have to write the struct keyword here. So every time we declare a variable of point type, means when we define a variable of point type, then we have to write struct here. Okay. But when we use type def keyword, okay, then at the when we use type def, so we will replace this struct point by point. So we don't have to write a struct again. So it will reduce the size of the code, and it will also increase the readability of code. Okay. So we just have to write point only. So generally, the most of the programmer uses type def to rename the long names like this struct point. So it will be only point. There is second way to do this. We can use type def, and then we can define our structure, and then we can rename it. So at the time of declaration only we can rename it. So it is also a valid thing, and we can use point p1 after that. So this is a very good use of type def. Means here we are just here we have to write 2 words when we declare a variable p1. So now we only have to write only 1 word, point. Similarly, when we use it for long, we don't have to write long 2 times. We just have to write L. So it will shorten our code, and it will also increase the readability of code. Okay. So yeah, this is about a type def and a struct keyword. Okay, so now let's study union. So union is also a user-defined data type, which is similar to structure. So it is similar to structure. Okay. So like we are accessing the members of the structure in union, also we can use dot operator to access it. Okay, dot operator. So to declare a union, we have a union keyword in which we have to give the name of the union. Okay. So the difference between union and structure is like that all the members of the union share the same memory location. Okay. So this is the main difference. And the size of the union is the size of the largest member in the union. Okay. So let's suppose I have a union test in which I have two variables int x, int y. Okay. So in this x and y will share the same memory. Okay. So there will be a common memory for both the variables. Okay. And since integer is of 4 bytes and integer y is also of 4 bytes, so the size of the union will be the maximum of these two values. So maximum of 4 comma 4 is 4. Okay. So the size of this union will be of 4 bytes. Okay. So when we calculate using size of operator, so when we calculate the size of test, so it will be 4 bytes. Okay. So here I have defined one union, and after that we have created a one variable for this union. Okay. And then we have assigned t dot x equal to 10. Okay. So when we print this, when we print t dot x and t dot y, so it will print 10 comma 10 because this x and y will use the same memory location. Okay. And when we do t dot y equal to 20, and when we print tx and ty, then it will be one second. So it will be 20 20. Okay, so this will be the output. Okay, so in union the same memory location is shared by all the members, and the size of the union is the largest member of the union. Okay, so let's suppose we have an union test in which we have a variable int I care ch 8, and then we have double d. Okay, so in this the size of integer is of 4 byte, size of care with uh, so this is an array of care with 8 elements, so it will be of 8 byte because each character element takes 1 byte memory. Then size of double is 8 byte, so the size of the union will be the maximum of this. Okay, so it will be of 8 bytes. Okay, so in this way we can calculate the size of union. Okay, so there is also one most important property of union, so let's see it by an example. Okay, so one second. So in this example, we have a union demo in which we have an integer I, then we have a character ch of 4, means it is a character array of size 4. Okay, so it is of 4 byte, it is of 4 byte. Okay, so the size of this union is size of union demo will be max of 4 comma 4, that is 4 bytes. Okay, so 4 bytes will be allocated to this union. Okay, so now after this uh, we come into the main function in which we declare a union demo d1. So 4 bytes memory will be allocated to this d1, and after we are performing d1 dot I equal to 5.12. So 5.12 will be assigned to this I. Okay, so when we print I, ch0, ch1, ch2, and ch3, so what will be the output? So we know that the output for this will be 5.1, but what will be the output for ch0, ch1, ch2, and ch3? Okay, because this int I and this character array of size 4 will share the same memory location. Okay, so it will contain some value. So what it will be? Okay, so let's see. So first let me represent this 5.12 in binary form. So it will be 0 0 0 0 0 0 0 0, then 0 1, because this 112 is 2 to the power 9. So if we have 0 1 2 3, 4, 5, 6, 7, 8, and 9. So here it will be 1 and others will be 0. And uh, and 0 will be there in the beginning. Okay. So this is the 16-bit representation of 5.12. But the integer is represented by 4 bytes. So it will be a 32-bit representation. Okay. So it will be a 32-bit representation. So in this, we have to we have 16 more 0 here. Okay. 16 more zeros will be there. So 1 second. So it will be 16 more zeros. So yeah. So let me write it here, it down. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0. So this is the 32-bit representation of this integer. Okay, integer I. Okay, 5.12. Okay, so let me erase this. Okay, now, so when we store this in this memory, so it will be byte 0. Okay, it will be byte 1. It will be byte 2. It will be byte 3. Okay, so it will store something like this. Byte 0 will be first, byte 1 will be second, byte 2 will be third, byte 3 will be this. Okay. So this will be the representation, and byte 1 will be pointed by ch of 0, byte 2 will be pointed by ch of 1, byte byte 1 will be pointed of ch by 1, ch of 1, then byte 2 will be pointed by ch of 2, byte 3 will be pointed by ch of 3. Okay, and the value of this byte will be 0 because all are zeros. Value of byte 1 will be, if we consider only this byte, okay, then it will be 2 because in binary it represents 2, so it will be 2. Then ch of 2 will be 0 because all are 0, and ch of 3 will be also 0 because all the characters are 0. Okay, so the answer for character 0 will be 0, character 1 will be 2, character 2 will be 0, and character 3 will be 0. So this will be our answer. Okay, so this is how the memory is shared between two variables. Okay, and the size of union is size of union, the largest data member in the union. Okay, and the union can be accessed using dot operator, and if we are using union pointer, then we can use the arrow operator for this. Okay. Dot and arrow operator. So similar to structure, we can use that to access the data members of the union. Okay. Yeah, so this is about the union. So let's move to our next topic, that is enum. So enum is also a user-defined data type. Okay, and it is used to assign names to the integral constants. So if we want to assign names, means since in our daily life we have weekdays in which there is Monday, okay, Tuesday, Wednesday, and etc. So there will be 7 days up to Sunday. Okay, and I want to define them as a constant. So as a group of constant. So I will write a enum is. Okay, in that enum I will define all this. So first constant name is Monday. Okay, then I will place comma. Then I will write second constant name, that will be Tuesday. Okay, and up to until all the names constant names are there. So then I will close the enum and then I will put semicolon. So it will define enum of days. Okay, and we can have a variable like enum days d1. Okay, and in this d1 we can assign Monday. Okay, so Monday will be, and when we print this d1, so the values will be assigned So first constant will name will be initialized with constant 0. Second will be initialized with 1. Third will be 2, and it will be in the incremental fashion. Okay. So Monday, or Tuesday will be 1, and similarly Wednesday will be 2, and something like this. Okay. So this is about the enum. So let's understand enum by example. Okay. Okay. So we have a enum. So enum is a day name, and we have Sunday first, then Monday, then Tuesday, then Wednesday, then Thursday, then Friday, then Saturday. So in this, the value of Sunday will be 0. One day will be 1, 2, 3, 4, 5, 6. Okay. So this 0 will be assigned to Sunday, 1 will be assigned to Monday, and similarly to others day. Okay. So this will be our enum, and when we create a enum object D and assign Thursday to it, and when we print this D, okay, so it will be Thursday is 4. So our output will be 4. Okay. And when we print from Sunday to Saturday, so it will print 0, 1, 2, 3, 4, 5, 6. Okay. So because Sunday is 0 and Saturday is 6. So we are printing from 0 to 6. So it will be our output. Okay. So enum is used to define the means some constants. Okay. Means if you want to define some category of constant. So suppose we have in calendar 12 months are there. So we can define enum of 12 months in which we can have something like this: March, April, June, July, etc. Okay, as an enum. Okay, and it will be assigned 0 to 11 values. Okay, then we have constant like small, medium. Okay, one second. Medium, then large. We have something like this, and we have to define it in a form of constant. Then we can define a enum for it. Okay, so if we want to store some means short data, then we can have small, medium, large, extra large, XL. Then we have double XL, etc. So we can define them as a form of enum. Okay. So there is one important thing. So let's see that in example 2. So we can also give the constant value at the time of enum declaration. Means we can assign 1 to Monday, 5 to Tuesday, 6 to Wednesday. But what will be the other values that will be get initialized? So it will be initialized by one more than the previous one. So here the Sunday is 1. So Monday will be 2. Here Thursday is 5, Wednesday is 6. Thursday means Tuesday is 5, Wednesday is 6, and then Thursday it will be one more than the previous. So here 6 is there, 7 will be there. Friday will be 8, Saturday will be 9. So when we print all this, so it will print 1 for Monday, 1 for Sunday, 2 for Monday, 5 for Tuesday, 6 for Wednesday, 7 for Thursday, 8 for Friday, and 9 for Saturday. So this will be our output. So yeah. So for Thursday, it will print 7. And for this print statement, this will be our output. So we can assign the value at the time of declaration. And if the variable is not, if other constant is not initialized, then it will get the value 1 more than the previous one. 1 more than the previous one. Okay. Okay, fine. Let's move to our next topic. So let's do one gate question based on this. Okay. So this is a very good question that was asked in IT 2006. Okay. So in this we have a struct in which two variables are there. So we have an integer I, and then we have a character star. Okay, C. And in this we have defined a character structure array. So we can have a structure array also. Okay. So we can define something like this: struct point and then we can have our array name is P, then we can declare its size. So we will have 10 elements of struct point type. So it will be an array of 10 elements of point type. Okay. So if we want a record of 10 students, so we can have a struct student as of 10. So it will contain records of 10. Similarly, here in this, we will have a struct of type struct test, and it will contain 1, 2, 3, 4, and 5 elements. So it will contain 5 elements. Okay. So let's see one by them, one by one. Okay. So we have this will be our array. So it will contain 5 elements. Okay. So the fifth element would be here. Okay. 0, 1, 2, 3, and we have 4 here. And this there will be two parts. One is for integer and another is for string. So here become will be there. We have 4 and better will be there. And we have 6 and in this jungle will be there. Okay. After that we have 8 and then ancestor is there. Okay. Then we have 7 and this brother will be there. Okay. So okay, so this will be our struct array and it will be pointed by st. So st will contain the address of the first element. Okay, 5 and become. Okay. So we have a p variable which is pointing to this st. So sorry. So this is not r, it is st. Then we have another pointer p which is present here. Okay, 5 become. Now we are incrementing this pointer by 1. So this will be incremented by the size of the structure. So the size of the structure will be, so in type, it will be 4 byte, and for character C star, so it will be the size of the character. Okay, so it will depend on the size of the array. So it will be the is the C size. Okay, so it will be incremented by this size 4 plus the size of C. Okay, so P will point to this 4 now when we increment P plus 1. Okay, so P will now point to this 4. Okay, and then we are so here we are doing pre-increment and then we are also using the arrow operator. So here we have to take care of the precedence of the operator. So in the previous lecture, we have seen the precedence. Okay, so I have written it here. So parenthesis are highest precedence, then subscript operator, then dot operator, then arrow operator. And after that, we have postfix, post increment and decrement. Then we have a post pre-increment and decrement. Then we have star operator, dereference, and then we have address of operator. So these three are right to left associated, and these are left to right associated. Okay, so here we are incrementing plus plus p, but arrow operator has higher precedence. So first p arrow c will be evaluated. So p arrow c value will be better. Okay, and in that we are incrementing plus plus. Okay, so here it will point to b and then it will again point to e. Okay, so here the value that is pointed by c, it will get incremented. So now c will point to this. So one second. So previously c was pointing to b, now c will point to e. Okay, and when we do p plus plus arrow c, so here arrow has more precedence. So first p arrow c will happen. So p arrow c is from e, start from e, we will print, so it will print ether. Okay, then the value of p will get incremented. Now p will come to the next index, so it will come to 6. Okay, means this 2 next entry. So p will be here. Okay, so let me erase it. Yeah. Now in this we are first taking star plus plus p then arrow. So we know that arrow has the highest precedence. So first this evaluation will get evaluated. So p's arrow c will happen. So it will print to jungle, means jungle will be there. Then we will increment it. So it value will be incremented. Now it will print here. So its C will be here or at U, and then we will take the value of it. Okay, so it will be U. So U will be printed. Okay, then C is here. Okay, then we print P of 0 of I. So P is currently here, and when we add P of 0, so P of 0 is something like this, star P plus 0. So it will be star P. Okay, so it will be here, and its value will be uh, 6. So 6 will be printed. Okay, so here 6 will be there. Then we have P arrow C. So P arrow C and C is pointing to this, so angle will be printed. So U and get printed. So here we have ether, then we have U, then we have 6, and here we have this. Okay, so the correct answer would be B. Okay, so the uh, answer to this question will be B option. Okay, let's do another question on gate. Okay, so it was asked in gate 2004 IT section. Okay, so in this they have defined a structure using type def keyword. Okay, so they are renaming it to T. Okay, and it contains two character pointer variable, and we have two function f1 in which s is there, and in f2 pointer of structure is there, type T. Okay, then we are defining one static T. Okay, so it will be a static variable, so it will be initialized only once. Okay, means it will not again be initialized. So here the s value will be a and b, and then we are printing s dot a, then s dot b. So it will print a comma b, sorry, a space b. Okay, then we are calling f1. So in f1 we are replacing this. So here in f1 we are passing this s, and this s is of type T, and here there is no pointer variable and there is no reference operator, means it is call by value. So here call by value is, this function is call by value. So the value of a and b will be copied. Okay, and that value will be changed to u and v. So when we print this, so u and v will be printed. Okay, and after that again we are printing s dot a, and then s dot b. So it will again print a b only, because there is no change in the s variable, because here we have used call by value. So the changes that we have made in the actual or in the formal parameters are not reflected in the actual parameters. Now when we call this function f2 with reference, so here this s will be pointed by a pointer variable p, which is of type t. So it will replace the value of a by v, so it will become v, and it will become w. And when we print this value, so it will become v and w. So our output would be AB, UB, AB, VB, VW, sorry, AB, UV, AB, and VW. So our correct answer would be B. So this is our correct output. Okay, let's try to do one more question on this structure. So this question was asked in Git CS 2000, in which we have struct node in which two variables are there, int I and int j, int I and float j, and we have a character array of we have a structure a node array which is a array of pointer type, and its size is 10. Okay, so the question tells us the abort C declaration defined as to be. So since it is a structure pointer array and it contains 10 elements, so it will be a array. So it is right. Each element of array will be a pointer to a struct type node. So yeah, it will be. So our A option will be correct. And here structure two fields. Each field contain a pointer to a 10 elements, so it will be a wrong option. Then three fields, no, there are only two fields. An array, each element having a structure of type node, it is also wrong, because here star is there, so it will be a pointer type. So A option will be correct option. Okay. Yeah. Okay, so it was a easy question. So let's do one more question. So in this, we have a structure, and in that structure, we have two variables. It is a short array of five, and then we have a union as a member. So we have declared union inside a structure, okay, in which float y is there and long z is there. And in this question, we have given that the short, so one second, the short will contain 2 byte, float will contain 4 byte, okay, and then we will have long which contain 8 byte. Okay, so in union, float and long will be there. So 5 and 8 is there. So maximum of 5 and 8 will be 8. So the size of union will be 8. Okay, and since short is of 2 bytes and we have 5 elements, so 2 into 5, so it will be 10 bytes. Okay, so the total size of this structure will be 10 plus 8, that is 18 bytes. So in this question, they have asked us the memory requirement, which is the size of this structure. So it will be of 18 bytes. So the correct answer would be 18. Okay, so yeah, so the correct answer is 18. So this is all about structure. Okay, so yeah, this is it for today's session. Thank you.